All right, hello everyone. I hope you all have a nice, relaxing weekend. The weather's getting nice out there finally. That's cool. Before we hop into today's material, I wanted to take a moment to talk about assignment one. So I'm sure you're all hopefully aware that the first assignment is due in your lab section this week, either on Wednesday or Thursday. And I'm actually not going to talk about the instructions, although if you have questions about what we're actually asking you to do, please chat to me after class or post a message on Piazza. What I would really like to talk to you about is actually down here past the instructions. This is the assignment one rubric. So this is publicly posted. We actually have a rubric for every single assignment in this class. And this rubric is quite literally what you are going to be asked when you show up to turn in your assignment. So when you come to class on Wednesday or Thursday and are ready to turn in your assignment to the one of the TAs at the beginning of class, they're going to pull this rubric up and just go right down the list. So, the first option's pretty trivial. Almost everybody gets those points. This one is quite literally the TA is going to look at your code, ask you to run it, and then give you a score from 0 to 10. Does it meet the assignment spec or not? Right? And so then I want to just highlight the fact that whether your code works or not, yes, it does matter, but that's a pretty small part of the grade that you're getting on this assignment. These demos that we're asking you to do, where you show your work to a TA, are really for you to demonstrate your understanding of the code, to demonstrate your understanding of the assignment. So the rest of the rubric that you see here, right? Student can explain what data type was chosen for Total Studios and why. That's a question that the TA is going to ask you. What data type are you using for Studios? Can you tell me why? Student can identify a line where scanner is used to read in a double. That's going to happen in multiple places, right? The TA is literally going to say, hey, show me a line in your code where you're using scanner to read in a double. And they're going to want you to do that. Show them the exact line. Point to the line number, highlight the line, whatever the case. But these questions are meant to demonstrate your understanding. So you should take a look at this before coming to class. You should prepare for this. We're showing these to you now so that you know what to expect. By the time you get to the TAs, the answers to this stuff should all be ready to go. If you sit there and like, oh, hang on a second, let me scroll through all this stuff and find the answer to your question, the TA is going to be like, sorry, I need you to show me that you understand this stuff. I'm going to give you a 0 on this part and move on to the next question. The demo is not the time for you to be figuring out the answers to these questions, right? You should figure these out ahead of time, be aware of what's going to be asked of you coming in, prepare. We want you to prepare. We want you to be aware of how your code is working. A lot of these questions are specifically about your code that you have written. So the answer that works for you is probably not going to work for the person sitting next to you. It's different code, right? So we're really asking you to take a look at the code, make sure you understand exactly what the code is doing, and that's what these questions are sort of intended to determine. So I just want to make sure everybody's aware of what's going on. Also want to make sure you're aware that if you don't get the assignment done by the due date for whatever reason, you're able to submit it late. There's policies on Canvas that explain how all of that works. You can also submit assignments early. If you want to come to office hours, you can submit assignments early, you can submit assignments late. It's totally okay. Most people do submit it when they come to class on studio days. We have the first 15 to 20 minutes of the studio basically dedicated to getting everybody's assignment submitted, and then the last hour of studio is actually working on the studio exercise for the day, right? So that's kind of what to expect when you come to class on Wednesday and Thursday. Does anybody have any questions about this before I move into today's materials? Happy to answer any questions. All right, not seeing any, so I'm going to go ahead and dive into today's topic. Just kind of want to, this is only the third week of class, and we weren't even here last week because of the holidays, so just kind of want to reiterate what these sessions are for, how I kind of hope things to go. I asked you to review these materials before coming to class. I realize there's a significant number of exercises here. I'm going to go through a good chunk of them, I would say even the majority of them today, but I just won't have time to do all of them. That's just not possible with the hour and 20 that we have in class. So I'm going to hit up, the highlights, the points that I think are most important. I'm going to ask you all some questions. We'll do some review of some concepts from last week as well, I'm sure. If there's any of the examples, you know, you were really hoping that I would get to, I want to know that. Holler at me, let me know. If it looks like I'm about to skip one of the examples, you're like, I really wish you did that. If you did that one, let me know, and I will be happy to double back and do it. Also, just keep in mind, right, I think it's definitely to your advantage to review this stuff ahead of time so you're not coming in completely cold. I also don't expect you to be entire experts on this stuff when you get in here. And there will be other weeks when you just don't get to it because you got a midterm or whatever's coming up and you just didn't have time to look at the exercises before coming to class. That's okay. I've given you that flexibility because I understand, right? Doesn't mean I want you to skip this stuff and blow it off. I'm just giving you the flexibility to do it in the way that you need to do it. So don't worry about it if you didn't get the exercises done for today. It's not a problem. Please do let me know if you ever need any help getting caught up on stuff like that, though. That's what I'm here for. Would love to sit down and chat with you in my office sometime and go through any materials that you need help getting caught up on. So, all of that being said, we're going to talk about two coding concepts today. The sort of title of this week's material is choice and iteration, where iteration is just kind of a fancy word for repetition, repeating things. We're going to start with the choice part. And in this particular example, we start off with a line of code right here. I'm in the very first example in Module 2, so all the stuff up here is from Module 1. That's from last week, right? So here I'm in the exercises repository, the very first module entry for Module 2, the file called test raining. This line is actually not new. This is stuff we've seen before. We saw this last week. What is this an example of? Can somebody tell me? A Boolean variable? Yeah. What am I doing with this Boolean variable? I am performing a blank operation. A declaration? That's true. I am declaring the variable. What else am I doing with it? Assignment. Yes, I was looking for that word, assignment. The key here is this equal sign, single equal sign. That actually is an operation being performed. That is an assignment operation. Right? That is an assignment operation. I'm taking the value from the right-hand side, putting it in the variable on the left-hand side. That's all review from last week. This is new stuff. So we didn't see anything like this last week. This is an if statement. If statements are how we make decisions in not just Java, but almost every programming language that I've ever encountered has some concept of an if statement being used to make choices, being used to make decisions. So we're really asking a question here. And the way that this code is written, you can kind of tell the question that we're asking. We're saying, you know, if it is raining, or I like to think of this more of a question as, is it raining? If the answer is yes, it is raining, or the way that we say yes in computer science is not yes, but true, right? Is it raining? True. Right? I know it sounds a little weird, but that's computers. Then I do the stuff that is inside of these curly braces. These curly braces, I would say, define the body of the if statement. So an if statement comprises of the word if, followed by parentheses. The thing inside of the parentheses must be a Boolean expression. There's actually multiple ways that we can write Boolean expressions. This is one of the more simple ways where we just, oops, I'm sorry, I didn't mean to click on that. Where we just click, where we just stick a variable in. This variable is either going to be true or false. So if the thing inside of these parentheses is true, I do this stuff. If the thing inside of this parentheses evaluates to be false, I skip it. I don't do this stuff. And I just jump to after the brackets, and then I keep going from there. So if we run this program as written, I see that it is true. That means that it's going to tell us to take an umbrella. If I make the simple modification to switch this to be false and run it again, you'll see that it does not tell me to take an umbrella. It just tells me to drive carefully. So this happened every time. It's not in the if statement. Stuff that's not in the if statement, that's going to happen every time. The stuff that is inside of the if statement, we make a choice. We use the information that's available to us to make a decision about whether we do that stuff inside of the if statement or not. Everybody with me so far? Any questions? One thing that's I get asked about a lot, or that can kind of help students comprehend this a little bit more. I'm making the argument that if I write something like this, looks a little bit different, I'm going to make the claim that this works exactly the same way. Do you see that? Hopefully. Think about the two outcomes. If the is_raining variable is true, well, hang on, let me take a step back for a second. What is this an example of? Is this variable assignment? No. What is it? It's a comparison operator. Specifically, what kind of comparison? Equality. We're doing equality. Is the thing on the left the same as the thing on the right? Are they equal? So if this variable is true, if true equals true, right, do the thing. If this is false, false is not equal to true, so this would be false and we'll skip it. I'm making the claim that the way that's written is the same as this. They're functionally equivalent. Potato, potato, as you might say, right? You might hear it. Which way is better? I don't know. Whichever way you understand the best is better, as far as I'm concerned, right? This is going to be a common theme in this class, though, and in fact, all computer science. There is not just one way to do things. There's always, almost always, going to be multiple different paths that get me to the same place. And many times, it's not honestly going to matter which one I choose. The one that you choose should be the one that you understand the best and makes the most sense to you, as far as I'm concerned. There will be other times in which the choice does matter, and I'll try to point that out, make it clear when those decisions are actually important. Okay, let's move along. Here I'm just asking either a true or false question. Either it's raining or it's not, right? It is or it isn't. But we can compare other things too, like numbers. So here, right up at the top, I'm generating a random number. And actually, we're going to go off on a little tangent here because this isn't necessarily directly related to today's topic of if statements and loops, but it is an important topic. We talked a little bit about random numbers in the Module 1 stuff last week. We're going to see random numbers come up again and again, including on this week's assignment. You're going to have to be using some random numbers too. So let's talk about this statement. The comment here tells us that I am generating random numbers from -10 up to +10. But I think more importantly is, do you understand how? And maybe even more importantly than that is, what if I wanted to generate, random numbers between any arbitrary values? What if I want to generate random numbers between x and y? Can I come up with some kind of a formula for that? The answer is yes, absolutely. In fact, that's what we're looking at. Let's break it down. Make sure you understand this. By the way, this is almost guaranteed to be on the upcoming exam in a couple weeks as well. I like asking questions about this kind of thing on the first exam. So let's pay attention to what's happening here. I see math.random. What kind of values does math.random give to me? If I say, hey, math.random, give me a number, it's going to say from 0 to 1, but never 1, right? I could get 0.2, I could get 0.678, I could get 0.999999999 repeating, right? Never going to get 1. Could get 0. It could possibly give me 0, but never 1. Okay, the values that I want to generate have a much wider range than that, right? Much wider than 0 to 1. So I wish to expand the range of random numbers that I'm given. The way that I'm going to do that is by multiplication. So the multiplication that you see here is based on the range. And I want to generate values from -10. Now here's the little wrinkle. From -10 up to +10. This is inclusive. I want to include +10, right? So how big is my range here? Be careful. It's not 20. It's 21. 21 is my range. 10 positive numbers, 10 negative numbers, and 0. That's 21 numbers, right? So that's why we're multiplying by 21 here. We multiply math.random by whatever range. So if I was doing the values from +20 to +50, right? The range that I would type in for that would be 31. Actually, if I'm inclusive of 50, it would have to be 31. And to understand why that's the case, 30 through 39, that's 10. 40 through 49, that's 10. 20 through 29, which I skipped, that's 10. And then 50, 31. So be careful of your bounds. Make sure you know exactly what your range is. Multiply by the range, whatever the range is, from lowest to highest. I'm going to multiply math.random by that range. So that'll scale the values for me. Then we just have to take care of what I call the shift or the offset. So math.random gives me values between 0 and 1. I can multiply to affect the range, but it's still going to start from 0 and end at whatever the range is, right? So from here, if I just look at this part, I now get values between 0 and 21, although not including 21, right? Up to, but not including 21. That's not quite what I want. So what am I going to do? I'm going to shift that whole range down by subtracting or adding the lowest value is actually probably a better way to think of it. Here, my lowest value is -10, so I'm going to subtract 10. That takes the whole range and shifts it down 10. So now it should be from -10 to +10. If I was doing from +20 to +50, this would be a +20 here, right? Take that 0 and shift it up 20. So 20 is the beginning of my range. Does that make sense to everyone? So, using this formula, you can make up random numbers in any range that you want. Let's say I did want to actually do, numbers from +20 to +50. All I have to do is change the range that I'm multiplying by and the offset that I'm shifting by to match the new numbers that I want. So here the range would be 31. Oops. And here this would be actually adding 20 to shift it up to +20 instead of down to -10. Just substitute in whatever your values are for the random range that you want, and you can use math.random to generate those values. One other thing that I want to point out here, I almost forgot this during the last section, but it's very important. What is this called that I highlighted? It's a cast. It's a cast. That takes something that is a double. So math.random is going to give me a value between 0 and 1. I scale it up between 0 and 21. I subtract 10, which gives me between -10 and +10. But it could give me 7.2. It could give me -6.25, right? If I only want integer values in that range, then I have to cast it. And when you cast it, it has the effect of chopping off the integer, just cutting it off. So if I run this code, I'm actually not even looking at the if statements down here yet. We're going to get to that in just a minute. I'm just looking at the random numbers that are generated. Let's take a look. If I run this code, it tells me -6. If I run it again, they should only be between -10 and +10, right? Should never be outside of that range. And I would encourage you to play around with this code, actually. Do the one that I had up here before, between 20 and 50. And then run the code again. Make sure it's only giving you values between 20 and 50. Make sure you understand how that works. Pick another range and figure out how to make it happen, because that's what I'm going to ask you to do on the exam. Write a statement that will generate a random integer between this number and this number. That's an exam question right there. Guaranteed. Any questions on this before I drop down to the second part of this exercise with the if statements in it? You're going to need this on assignment 2, by the way. Not assignment 1, but assignment 2. You're going to need to do some random number generation like this. Yes? Okay, so the reason why it's 21 instead of 20 is because this does not include 1, but this does include the upper bound. That's why there's the discrepancy there, yes. It's a good question, one that I get a lot, yeah. Any other questions? All right, so assuming that we are at least somewhat okay with this random number generation, or at the very least you can accept this, this statement that I'm generating a random number between -10 to +10. We're now going to ask a series of questions. So here I'm asking not just one question, but I'm asking 2 questions, right? I'm asking, is this number positive? And if it is positive, which you can see I'm doing with a, what's this operation called? Greater than, yes, but greater than is an example of what kind of operation? Equality, I would call it a comparison, relational. Right? Comparison, relational operators, I think, are used interchangeably. Relational operators. How does something relate to something else? Greater than, less than, equal to, those are all examples of relational operators. Okay? So if it's positive, I do the thing that's in here. But if it's not positive, then I skip it. And then I'm asking another question. If it's 0, I do the thing that's in here. And if it's not 0, then I skip it. And the exercise up here says, add another if statement to check for negative numbers. Okay, I mean, we're going to ask a third question down here. If the number is less than 0, then we'll just print out that it's negative. There we go. And you can, of course, run this until you get a negative number. Hopefully it doesn't take you too many tries. Oh, I got one on my very first try. There we go. Tells me that -3 is negative. What is this operation, by the way? It's not addition. Concatenation. Concatenation. How do you know? How do you know that it's concatenation and not addition? You're partially there. It's not two strings. I look on the left, I say, all right, that's a number, right? So far I'm kind of feeling like addition. But then I look at the thing on the right and I say, oh, that's a string. Must be concatenation. So the types of the things that I am using in my operation determine what that operation is. If this had been another number on the right-hand side, it would have been addition. But it wasn't. It was a string. And that presence of that string means that we're doing concatenation. Great. Awesome. One other thing I want to point out about this example that is sort of a little bit of foreshadowing, right? Here I am asking 3 separate questions. I'm saying, is it positive, is it 0, is it negative? But these are kind of related, aren't they? In other words, there's no way it could ever be positive and negative at the same time. That's not possible. These questions are sort of connected. There's a connection between these questions that I'm asking. And it would be nice if we could reflect that connection in our code. There's actually a way that we can do that. We'll get to that in a little bit. But before we move on to that next topic, let's take a look at some common errors that I see when students are writing if statements. This is by far one of the most common and annoying if statement errors that you can make. I understand it. I see it all the time. Every semester, somebody runs into this problem. And in some sense, it's a good thing, right? I love that you're getting used to sticking semicolons on the end of our statements. However, semicolons don't go here. It can. You'll notice that Eclipse is not complaining. I can run this code, actually, and it will run. But it's not going to do what I expect it to do. This semicolon basically says, I have the if statement, I have my condition, and then the semicolon says, oh, if statement's over. So it's the world's shortest if statement. Literally does not do anything. Nothing. Instead of a semicolon here, I want to see curly brackets. Curly brackets here. If statements have curly brackets, not semicolons. And then remember that the semicolons go around the statements that we want to be tied to this conditional, and that should be reflected in the format of the code. So while this is also technically correct in that it will run, right? The computer doesn't mind. It doesn't look quite right. I would prefer that these two be indented. And you could fix that yourself by just manually indenting, but I would like to show you a shortcut, one that I use very often. And it's very handy. If you hit Control-A, followed by Control-I on a Windows machine. On a Mac, it would be Command-A, Command-I, I believe. You can see that it automatically fixes any indentation problems that exist within this file. I would encourage you to use this regularly. The indentation, while it doesn't actually change how the code works, makes it makes it a lot easier to understand what's happening. I can guarantee that if you come into office hours, either mine or the TA's, with code that is, all over the place, one of the first things we're going to say is, hey, let's clean this up. I can't really tell what's going on here. Let's clean it up. Let's make sure that it's formatted well so that we can actually understand the flow of this code. Can you have stuff like this in your code? Yeah, sure. That's allowed. Eclipse isn't complaining. It's not mad. Eclipse also isn't going to complain if I do this. It's still there. It's still going too. It's like all the way out the door, and Eclipse isn't going to care. That line of code is still there. I can't see it. I mean, I can if I go looking for it, right? But this isn't a nice thing to do to somebody, especially yourself, when you're working on a homework assignment. Indent your code properly. Take the time to do it. Run the Control-A, Control-I often. Let Eclipse fix your indentation. It's such a useful trick. Not going to be the last time you hear me mention this trick in class. Yes?
Why Control-A works, so why Control-I doesn't work?
If you're on a Mac, then you may need to look up what the hotkey is. What I actually did, if you're trying to find it in the menu, is correct indentation right here. So for me, you can see it very clearly says Control-I. Yours, I guess, says something different. Do whatever it says.
Okay. Thanks.
Not a Mac person, as you can see. I have less familiarity with Macs than PCs. All right. Any other questions before I move on to the next one? Cool. Then we're going to move on to this one that's called driver's test, and we're going to introduce another part to our if statements. So before I mentioned how I had an example where I was asking 3 questions, but actually those questions are kind of related to each other. It would be nice if there was a way to tie them together somehow. And so here's one piece that we can use to kind of, structure the questions that we're asking slightly differently. In this case, I'm checking your age. I'm saying, hey, are you older than 18? And if the answer is yes, then I'm going to say, yeah, you're old enough. You can get a driver's license in most states. And if you're, younger than 18, less than 18, then it's going to say, sorry, you have to be older before you can learn how to drive. Notice, though, that I don't have a condition down here, right? This else statement doesn't have a condition associated with it. It's basically saying, if this is false, then just do this thing. I don't need to check anything else. This is not true, so I'm just going to do this instead. It will always do exactly one of these options, though, right? So doing nothing is actually not an option here. It's always going to do either this one or this one or the other. The way that I would actually say that is that there's an implied condition here. If I get down here, I know for a fact that age must be less than 18. I don't actually need to say that, though, right? It's implied. Because age is greater than 18 was false, then logically I must know that age is less than 18 when I get here. So we don't actually have to write that condition out. The else just captures anything that is false from the first condition. And I would like to run this and show you that that is in fact what happens. So if I type in, oh, there's no prompt here. That's not very nice. There should be a prompt here. But I know what they're asking for, so I'll just type in a number like 26, which is definitely not how old I am, but it tells me you can get a driver's license in most states. And if I run another number like 13, which is too young, it'll say, sorry, you have to be older to get a driver's license. Again, I want to point out what this if statement is doing as opposed to the last examples. The last examples, I either did the thing or I didn't. This is more like a fork in the road. I have to do one of them. Have to. Am I going to do the first one or the second one? That depends on the evaluation of the condition. But I have to do one of them. I have to take one. Make sense? Everybody with me so far? Okay. Then let's move on to our next one. Here, we see an example. It's asking a very simple question. It says, did you pass the midterm exam? The answer to that is either going to be true, yes I did, or false, no I didn't. And I want to do something similar to before where I have a fork in the road, right? I make you pick one of those two options. Either I'm going to say, hey, good job, give you a pat on the back, or I'm going to be mean jerk and make you feel bad and say, study harder next time. I would never say that to you. That's not a very nice thing to say to somebody. The computer said that, not me. Right? But the point of this example is actually to pay attention to how it's structured. Here, the way that it's written, I'm asking two questions. I'm saying, did you pass the exam? If so, yes. Did you not pass the exam? So this is saying not pass the exam. Think about what that means. If this is true, the not turns this to be false, right? Which means it would skip this. If this is false, then this turns this into true, which means it does the thing inside the curly braces, right? But the bigger issue is that if this is false, then I don't actually even have to ask this. It's redundant. I've already asked the question up here. If I know that this isn't true, then why am I even asking this? It's redundant. Furthermore, these are connected. These are related to each other, right? These are two possible outcomes that I want to take. The way that this has been written, though, it's like asking two separate questions. So while this is technically correct, I wouldn't take points off for this on an exam, for example, or an assignment. I wouldn't take points off for this. This is technically correct. I think it is cleaner and honestly easier to understand if you simply replace this with an else. There's no need to write that condition out again. It's not necessary. It's extra. It's redundant. It also more clearly mimics the fact that these two conditions are related to each other, right? They're not independent. They are not independent of one another. The way that it was written originally with two separate if statements kind of implies that those are two separate independent things that I'm asking about. And that's not true. They're related. So we would like to have our code reflected that way. This is kind of an ambiguous area where, if you don't write it as an else, it could still correctly work. But we're going to see some examples of where that may not always be the case. But before I do that, though, let me introduce one more thing, one more concept here. Before I had two options. I'm either going to go left or I'm going to go right at the fork in the road, right? But what if there's more than two options? So what if I'm picking between more than two options? And in this example, I'm picking between, 3 options, but I'm not limited to 3. I can actually have 10 options or 20 options or 100 options, right? The computer doesn't care. There's no limit. So instead of having multiple if statements, we're going to use this construct to chain them together. Chain these conditions together. This is one if statement that has 3 possible outcomes, as opposed to writing 3 separate if statements, each with their own possible yes or no answers. Let's run through this code just to make sure you understand how it works. When I have an if, else like this, I am guaranteed to pick one of these 3 options every time through this if statement. Guaranteed. Which one am I going to pick? Well, it depends on the conditions. Right now you can see that x is set to be 2. So I look at this value and it says x is less than 0. That's false. All right, so I'm going to go down to this one. It says x is equal to 0. That's also false. And so then I go down to the else and there's nothing for me to check, which kind of makes sense, right? If x is not negative and x is not 0, therefore x must be positive. That's the only thing left for it to be. So it doesn't ask the question, is x positive? I already know. I know it's not negative. I know it's not 0. Therefore, it must be positive. And this is the option that will be taken. In fact, we can run this, show you that. X is positive. If I manipulate the values, so let's say I make x negative 7, what's going to happen this time? It'll look at this statement, it'll say x is less than 0. That's true, so it will do this thing, and then it's not even going to bother to check this. And it's definitely not going to bother to check this. Remember, it's going to take exactly one of these paths. It found the path that it wants to take, so I'm not even going to bother checking this. This is the correct option. So if I run it with a negative number, I do the thing in the first brackets, but I ignore the others. I don't even check them. And then, of course, if we set it to 0, our third condition here, and run it, it's going to say x is less than 0. 0 is less than 0? No, that's false. Even for exceptionally small values of 0, that is false. So I skip down here and say, is x equal to 0? Yes, it is. This is my option, and then I'm done. I no longer have to check anything else. I am now finished. You can run the code and see that that is the case. This is very common, to have multiple possible outcomes and have to specify it using a series of if, else, statements like this. Again, this makes sense here because these are all related to each other. It's up to us as programmers to make that distinction, though, right? If I'm truly asking two separate questions that are not related to each other at all, then having two separate if statements is the right way to go about it. Don't force your if statements to be chained together with else's and else-ifs if they're truly doing two separate things, right? But in the case where you do have more than one option, using an else and else-if are very handy. And in fact, I would like to illustrate why that's so important with another example. But before I do, does anybody have any questions about the else-ifs or the else? Yeah, so I can have as many as I want. So if I come, in this case, it doesn't really make sense to add another one because I don't know what else a value can be besides positive, negative, and 0. But if I really wanted to, I could say else if x is, whatever. Oh gosh, not that. Right? X is something else, and then I could do some more stuff. And then if I wanted to, I could say else if, and then, right? I can keep going. I can have as many else ifs as I want. You can only have one else. So you can have as many else ifs as you want, but you can only have one else statement, and it's always going to be at the very end. Another way of thinking about the else statement, it's kind of like a catch-all, right? If everything that I checked for before didn't work, here's what I want you to do. Here's the default. You might hear it referred to as that in some situations. It's just the default option. Everything else that I checked didn't work, so here's what I want you to do. Also, keep in mind, though, that else statements are optional. You do not have to have an else statement. Sometimes the most appropriate thing is going to be to have an if statement by itself. No else ifs, no else's, no nothing. Sometimes the most appropriate thing might be to have an if, else if, with no else on the end. Sometimes it might be appropriate to have something like you see here. It is your job as the programmer to make sure the code matches the problem that you're trying to solve. So you have to use the tools that you have available in your toolbox, the if, the else if, and the else, to try and make the code match the problem that you're trying to solve as best as you possibly can. And there often will be more than one way to do it. That is a fact. But that's still your task as a programmer. Great question. Any other questions? Yes? Why having too many else ifs is problematic? I don't know that it necessarily is problematic. I mean, it's problematic in the sense that if I have a big old chain of these things, it's going to be hard for me as a human being to go through all those different options. That's kind of inconvenient. But if it, again, if the code matches the problem if the problem I'm trying to solve has 10 outcomes, I might need 10 else ifs, right? Like that's a thing that could happen, for sure. In fact, I think the next example might make that point a little bit more clear. Let's take a look at this example called if debug. We're doing a classic thing here. I have a score variable up here at the top, and I'm trying to take this numeric score value and convert it into a letter grade. We're not even worrying about pluses or minuses here. That's more complication than this example needs. I'm just trying to give you A, B, C, D, or F. And so, here's my score. It's a 93. That's a great score. That should be an A, right? It seems like that would be an A in pretty much every class. In fact, that would be an A in this class too. But if I run this code, it tells me I have a D. And now I'm very confused and disappointed because 93 should not be a D. What the heck happened? Let's run it through the debugger and see if we can't figure out what happened. I actually already have this set from last. What is this? This little circle over here? Breakpoint. Yeah, I already had this set from last time when I went through this with the prior section. So my breakpoint's already set here from before, but to set the breakpoint, you just double click it to turn it on and off. That's usually what I do. So I'm going to set that breakpoint right on the very first line, line number 8. That's just where the code is going to pause when I run this in debug mode. So that's what I'm going to do next by clicking the little bug up here after I set my breakpoint. It's going to ask me to switch to debug mode, which I will gladly do. And here I am. I'm paused at line number 8. Nothing has happened yet, but I'm about to walk through the code one line at a time and see if I can figure out when things start to go off the rails. All right. In order to do that, up here at the top, there's a yellow arrow. It's called Step Over. That's the button that I'm going to use to walk me through the code line by line, and I can examine things as they happen to see what this code is doing for me. So I click the step button. First thing that I see is my score variable got created and set to be 93. That seems pretty straightforward. I take a look at this next line. It creates a variable called grade, and this might look a little bit silly, but it's actually pretty common. We have a name for this, in fact. This is the empty string. Quote, quote, there's nothing in between. It's an empty string, literally a blank string. So that's not an uncommon thing to see, even though it does look a little bit silly. Just a blank string. Eventually, we hope to replace this blank string with whatever the letter grade is, right? So that's kind of what we're trying to do next. And here we are. We're asking our first question. Is the score greater than 90? Well, yes, it is. So I should get an A, right? So I hit the arrow, and here I am. It says I should get an A, and in fact, there is my grade. It says A now. All right. So far, everything seems to be going okay. I'll get to your question in just a second. Let's take a look at what happens next. Now I'm asking the question if the score is greater than or equal to 80. Well, it is, right? 93 is greater than or equal to 80. So I click the step button again, and now I have a B. Well, wait a second. You just told me I had an A a second ago. Now I have a B. Well, now it's asking if the score is greater than or equal to 70, and it is. 93 is greater than 70, right? Well, now I have a, hold on, what? So we get down here. Finally, I have this statement that says, score is greater than or equal to 60. It's going to give me this D. We saw that. There's an else statement down here that is attached to this if statement right here. So at least I skip this and I don't get the F. That's sort of a nice consolation, I suppose. But still, I end up with the wrong grade at the end. Why? What's the problem? How do I fix it? Yeah. I need else ifs. These should all be else ifs. And I really hope you understand why. Because the way that it's written right now, I am asking 1, 2, 3, 4 separate questions, right? I'm asking 4 separate questions. I have 4 separate, independent if statements. There is an else on one of them, right? But they're all independent from one another. They're all asking their own separate questions. That's not what I wanted. And it also doesn't match my problem. I'm not really asking 4 questions. I'm asking 1 question. Here's a grade. Turn it into a letter. That's one. That's one thing. So the code does not reflect the problem that I'm trying to solve. In order to reflect the fact that these are not independent, these are actually related to each other, we need to make these into else ifs. You can think of the else ifs as chaining these together, right? I am now chaining these together. Instead of having a series of multiple if statements, I now have one big if statement. And the advantage of having one big if statement like this is that I know it's going to do at most one of these things. And actually, because I have an else statement on the bottom, I know for a fact it is going to do exactly one of these things. If the else statement isn't there, it's possible that everything is false and I do nothing. But since the else statement is there, I know I'm going to do at least one of these things. Right? So if we run the code again, thinking about our score of 93, what's going to happen? It's going to get to the very first if statement right here and say, yes, that is greater than 90. Your grade is an A, and then it's not even going to bother to look at the rest of these, right? it found the correct option. Those are now all chained together, so it's not even going to check the other conditions. We've told it that, you know, it only needs to pick one of these. And we can just run the program again to see that, oh, hang on. I need to switch back to my Java perspective and then run the program again. There we go. We can see that I get my well-deserved A after fixing that problem. Question, yeah.
If you scroll up a little bit to the variable declaration,
Mm-hmm.
is there any practical benefit or difference of assigning it an empty string versus just declaring it and not assigning it anything?
So the question was, is there any value to having this as opposed to something like this, right? In this particular example, I'm not sure that it would make a difference. In fact, I can even run it and see if it complains or does anything, which it doesn't. So in this particular example, no. However, I want to draw your attention to the case where, let's say I don't have this else statement on here, which is, it's possible, right? I don't need to have an else statement. Else statements are optional. That means that it's possible that this could be false, this could be false, this could be false, everything could be false, and then I never set anything to it. So it's just completely, if I go through this and everything is false, then what is the value of grade? I never told it anything, and that could cause problems.
Would that spit out an error, or would it just...
It could. Depends on what you try to do with it.
Just printing it wouldn't be an error?
I'm not actually it is. Yeah, you can see. It's telling me there's a problem. Yeah. So it depends on context. Yep. Great question. Love the way you're thinking about this. Any other questions on this example before I move on to the next? Yes? The empty string is quite literally a string that contains nothing. It's a placeholder. It's a blank string. It's like looking at a form, you know, that says, hey, what is your name? Before you write anything into that box, that name field contains blank. It gives grade some sort of value so that it's not just undefined. Because if I take this off, grade is quite literally undefined. Much similar to the idea of undefined in math class. What is it? Unusable. Yeah. I almost never declare variables like this. I can't think of a reason that I've done this outside of just, you know, showing somebody what can and cannot be done. If I'm actually writing code to be used in a professional way, almost always. I can't think of any time that I have not initialized a variable when I declare it. Yes? You could declare this inside of each if statement, but that's going to look really redundant and nasty to me. Couldn't I do what?
Instead of just like having the string variables,
I could, but this isn't accurate.
inside of each
I mean,
what's the difference in setting it outside of it?
if I do it, if I set this inside of the if statement, I'm going to have to, if I take this out and I set it inside of the if statement instead, right, this string doesn't exist yet, so I have to create it here. Oh, I think I understand what you're asking me now. Sorry, it took me a minute for my brain to catch up to your question, but I think I understand what you're asking me now. If you create it inside of the if statement like this, this actually is an issue that we call scope. Because it was created inside of the if statement, it cannot be seen outside of the if statement. So variables can only be seen where they are created. Since it's created outside of the if statement before, that means it can be used outside of the if statement. Yes. That's a concept called scope, and that is a concept that we'll see in a week or two, I believe. Yeah, come up in a lot more detail. Yeah, great question. Any other questions? Alrighty. Let's see, which example am I on next? I'm going to hop to the chores example next. and take a look at something called a compound operator. So you actually got a little taste of this in Studio last week, or you should have if you got that far in Studio. You can also go take a look at the Studio review video if you didn't get that far for whatever reason. But just wanted to take a moment to formally talk about what these compound operators are. So these are used when we have more complex kinds of conditions, right? What if I'm checking for more than one thing? So in the past example, I was saying, is this value positive, negative, or 0? What if I want to ask, that question and this other value is 7, right? So that word "and," very, very critical word in there, I can use this operator, which is called the "and" operator. What that means is it looks at the thing on the left. That's either going to be true or false. It looks at the thing on the right. That's going to be true or false. The result of the "and" operation will only be true if both the left and the right-hand side are true. If one or the other of the things that appear on the left or the right-hand side of that operation are false, or if they're both false, then the "and" operation is going to be false. So if I look at the way that this problem is set up here, it tells me true, false. So cleaned room is true. True and false is false. So this if statement is going to evaluate and be false. So it'll jump down here to the else statement, right? If I switch it so that this one is true and this one is false, it's the same story, right? This one is false, and actually the computer is smart enough that if it looks at this and sees that it's false, it doesn't even look at this one, right? All it needs for this operation is one false, and I know what the answer is. It's only true if both things are true. And that makes sense when we say it out loud as well. I have a 13-year-old stepdaughter at home, so I talk about this kind of stuff all the time. If you've cleaned your room and you've done your homework, then you can go out. That's max dad mode, right? Like, I'm there. That's my life right now. So that's the "and" operation. Both need to be true in order for the operation to be true. There's a corresponding one. So if I look at the transportation example, the operation that is sort of the complement of the "and" operation is this one, which is a little bit less intuitive. I would pronounce this as "or." And this character right here is called a pipe. That's the official technical term for that character. It appears above the enter key on your keyboard. If you're looking for it on your keyboard, that's where it is. Notice there are two of them, so the two pipes next to each other. That is called the compound "or" operation. And as the name kind of implies, right, for this one to be true, the left-hand side or the right-hand side have to be true. One or the other, or both. If they're both true, still true. For this one to be false, both the left-hand side and the right-hand side have to be false. So, in this particular case, right, I'm trying to decide how I'm going to get somewhere. So I'm asking, is it within walking distance? Is there a car available to me? If it is not within walking distance, if it is within walking distance, or if there's a car available to me, then I can go, right? If it is not within walking distance, and there is no car available to me, so both of these things would have to be false, right? If it is within walking distance and I don't have a car, who cares? I can walk. If it's not within walking distance, but I have a car available to me, who cares? I can drive, right? If one side is true, still true. One side or the other, or both, still true. But if this is false, if I can't walk and I don't have a car available to me, this will evaluate to be false, and so I can't go out. I can't make it to where I'm trying to go. Make sense? Yes?
I just want to ask, why would you assign within for walking cars available with cars? Why would you assign them as false?
Why would I assign these value? I'm not sure I understand the question. I mean, I have to assign.
You said it equal to false. Is that how you?
This is just an example where you're, intended to switch these between true and false and examine the different paths through the code. That's all that this example is set up for. I'm not sure I'm fully understanding what you're asking of me, though. this could be anything that evaluates to true and false. So if I wanted to, I could say if 7 is greater than 0 and a car is available to me. That's fine. 7 is greater than 0 is true. So I can put that there, right? Any Boolean expression is good there. Whether that's a variable, whether that's a comparison that's going to evaluate to be true or false, compound operations. In fact, you'll start to see things get pretty complex. It's not unusual to see conditions that use multiple compound operators, right, with parentheses to separate out. Something like this. X doesn't exist, so that's why Eclipse is mad at me, but otherwise this is a perfectly reasonable thing to say. This is a perfectly acceptable thing to say. So the conditions can get quite complex. That's the point I'm trying to make. That's a good thing. That gives us more flexibility in terms of the types of questions we can ask, the types of decisions that we can make. But it also does, it's more complex, so it's a little trickier to understand, a little trickier to figure out. That's the trade-off. That ends the choice part of the discussion. We're about to move on to the iteration part next, but are there any questions before I do that? Move on to the next topic. Okay, great. Then I'm going to go ahead and move down to the module 2.5, which is the labeled while. And we're going to look at a loop next. Specifically, we're going to talk about the 3 components of a while loop. And kind of contrast that with the if statements that we've been working with. Step number 1, we're using we're initializing something that is called the loop variable. So the loop variable is just a variable that is used to control the number of repetitions that a loop will have. So a loop is used to repeat something, as you'll see very clearly here in just a moment. The loop variable is used to control how many repetitions there are. That's its purpose in life. So we're just starting our loop variable at 1 in this example, and then we get to the actual loop. It looks very similar to an if statement, right? Very similar to an if statement. Let's talk about how it's different. Obviously, this is different. It says while instead of if. Whoops. So how does that affect the code? Well, it's going to do a similar sort of thing. It's going to ask this question: is count less than 5, less than or equal to 5? If the answer is true, then it's going to do the thing inside of the curly brackets, just like an if statement. That is all so far the same. Unlike an if statement, if this evaluates to be true, then when it gets down to the bottom of the loop, it's going to come back up to the top and ask this question again: is count is count less than or equal to 5? If the answer is true, I'm going to do the stuff in the loop again. I'm going to repeat it. And then I'm going to go ask that question again: is count less than or equal to 5? And now, if the answer is true, I'll repeat it. If the answer is false, then I'm done. I just say, oh, this is false. The repetitions are over, so I'm just going to jump down to the bottom and then do whatever's next. Do whatever's down here. In fact, I often like to kind of tweak this by putting a little statement down here at the bottom that just says loop over, just so I know, right? So that's part 2. We initialize the loop variable. We have a test for the loop variable. While the test is true, we keep repeating. As soon as the test becomes false, I stop. And then the last part, but certainly not least, is we have to update the loop variable somehow. So in this particular example, I'm saying count plus plus. What does that do? It adds 1 to it. This was actually in last week's materials if you need to go back and review. Or if that bothers you, here is an equivalent line of code, right? This does exactly the same thing as plus plus. We just do this a lot and we get tired of typing it out, and plus plus is a lot faster. That's... We'll get there. Hold on to that thought. We'll get there. I love that question though. Let's go ahead and take a look at how this code is actually working, right? Make sure we understand what this loop is doing. Here, if I run the code, you see count starts at 1. It then says, is 1 less than or equal to 5? Yes, it is. That's a true statement. So I'm going to print out the value 1. I'm then going to add 1 to it, which makes the value now 2. Then I'm going to go ask the question again. Is 2 less than or equal to 5? Yes, it is. So I'm going to print it out, print out 2, and then I'm going to add 1 to it. It is now 3. And we'll keep doing that. 3 is less than or equal to 5. 4 is less than or equal to 5. 5 is less than or equal to 5, right? Then this becomes 6. And 6 is not less than or equal to 5. That statement becomes false. So the loop is over. It stops repeating after the 5th time through the loop and tells me that the loop is over. Everybody with me? Any questions about that? So if I wanted to make this loop run from 3 to 5, what would I change? This would become a 3, right? Change the starting value, change the initialization, and now I have something from 3 to 5. If I wanted to go from 3 to 10, I would change this part, right? This says stop when you get to 5. If I change that to 10, it'll now keep counting up until I get to 10, right? So there I now have values from 3 to 10. What if I wanted to count from 2 to 10, but I wanted to do it by 2s? 2, 4, 6, 8, 10. Could I do that? Sure could. Which part am I changing? Change this guy, right? Change that to be a 2 instead of a 1, and now I'm counting up by 2s every time instead of by 1s. What if I wanted to go backwards? What if I wanted to start at 10 and count down? I can do that. It's a little bit more than just switching this to be minus though, right? I also need to switch this to be 10. And I also need to switch this to be 2. And perhaps most importantly, right, I'm now starting big and counting down. So this is not going to be less than or equal to. This is going to be greater than or equal to. Do you see that? But it still works. I can go ahead and run it. Ten, 8, 6, 4, 2. Yeah. So just by manipulating these 3 pieces, the initialization, the test, and the update for the loop variable, we can generate any series that you can possibly conceive of. And this is very common. This is a very common thing to do. Very common thing to do. There are some pitfalls. There are some things to be aware of, some common mistakes that I'd like to point out to you. In this particular example, we want to print out the numbers from 1 to 8. And it looks like I've gotten a start on this, but let's go ahead and run the code and see what happens. Oh boy. So I see the number 1 coming, and it's actually still being printed. If you look at my scroll bar over here, if you can see it, right? It's printing 1, a whole heck of a lot. In fact, I mean, what I really have here is an infinite 1 printing machine. I could get up and, go home and come back tomorrow, and it would still be sitting here printing 1s from now until the end of time. It's probably not what I want. In fact, very specifically is not what I wanted. I expected to see, numbers counting up from 1 to 8. What happened? What am I missing? Yeah. I'm not changing the value of count. Right? The value of count starts out at 1. 1 is less than 8. That's true, so I print out the 1. And then count is still 1. 1 is less than 8. That's true, so I print out the 1. 1 is less than 8, so I print out the 1. And that keeps happening forever and ever. I'm missing the third part. I'm missing the update. The value of, let me rephrase that. As computer scientists, when we're writing loops like this, we have to ensure that this will eventually be false. That has to eventually be false. Otherwise, this loop is going to run infinitely. This is an example of an infinite loop. This is usually not what we want. We usually don't want infinite loops. If you find yourself in this position, you can click the red square here, and that should stop. So you can see after I clicked that red square, it stopped the execution. If that doesn't work, you might need to restart Eclipse. That's happened to me before. But usually the red square gets the job done. The reason that happened again is because we didn't update our variable. As programmers, it's our job to make sure this will eventually be false, which means that count eventually has to be greater than 8. And if it starts as 1, the only way that's going to happen is if it goes up. So I need to make sure that it goes up. If I run this code again, you can see it's not going to be infinite this time, but we are still a little bit off. This is another classic error. We want our loop to count from 1 to 8, and I see 1 and I see 8. But then when I look here, I only see it goes from 1 to 7. Classic error. This is an off by 1 error. Pay attention to your signs. I mean, there's a few ways you could fix this, right? I could fix this by changing this to be not just strictly less than, but less than or equal to. That would get me there, right? Or another way I could fix that is by changing that to be a 9. Because 8 is strictly less than 9, correct? Both options will get me there. Doesn't really matter to me which one you pick. Whichever one feels, most understandable, most correct to you is good with me. Don't have a problem with either one. But now with those problems fixed, we can see I get the values I wanted from 1 through 8. All right. So we end up writing loops like this all the time. In fact, it's so common that a while back, and by a while back I mean even before I was around, this has been part of computer language for many, 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 many years. Somebody said, all right, let's take those 3 loop components and instead of having them all spread out in different places, let's put them all in one place. And thus, the for loop was born. The for loop has the exact same 3 pieces that I showed you for the while loop. The biggest difference is that they are all tucked in right here, in the same spot, right at the very beginning of the loop. So that you can just look at the for loop and see them all there. To where before, imagine if you had a while loop that was 100 lines long and your update statement is buried in there somewhere, right? You got to go track it down and find it. So this is just a little bit more convenient, a little bit easier to use, at least, that's subjective, I suppose, but a lot of people consider this to be an easier, more straightforward way to run things. But consider this example, and the very first one that I showed you here, if I put it back to its original form. So this example counts from 1 to 5 using a while loop. I can show that to you. 1, 2, 3, 4, 5. 1 through 5. This example, the for loop example, does the exact same thing, just using a for loop instead of a while loop. So here you can see is the first part, the initialization. Here's the second piece, the test, the conditional statement, and then here's the third piece, the update. They're all there. They're just in a slightly different spot. And you're going to come across many situations in this class where you need some sort of repetition. You need a loop, and so you might be wondering, well, should I use a while loop? Should I use a for loop? I'm happy to tell you that for a lot of the situations, it doesn't matter. You can use whichever one you want, whichever one you feel most comfortable with. That's not a problem. However, there are some situations in which one choice will clearly be better than the other. For while loops work very particularly well when I don't know how many repetitions I'm going to need. So for example, imagine that you're playing a simple guessing game, right? You have a person sitting at the computer, you say, guess a number between 1 and 100. How many times is it going to take them to guess that number? They could get it right away, right? They could get it on their first try, or they could sit here and it could take them a whole bunch of guesses. If they're really not particularly bright, it could potentially take them an infinite number of guesses, right? If I just sit here and guess 2 over and over and over again, the computer's not going to stop me from guessing 2 over and over and over again. So I could sit here and guess 2 from now until the end of time if I wanted to, right? A while loop is going to be the best fit. I don't know how many times it's going to take before they give me the right answer. So a while loop's a good fit for that problem. If you know how many repetitions you need, how many iterations you need, then the for loop is generally considered the better fit. I need a loop that's going to run 100 times. For loop. Every time, for me at least. That's what I'm going to do. It doesn't even have to be that specific. I need a loop that is going to repeat X number of times. Good enough for me. I'm going to use a for loop for that. It's a perfect situation to use a for loop. In the other situations, you really have a choice, and I'm not going to be picky. You can pick whichever one you want. Although I will say, just from experience, that people tend to prefer this one. So you will probably write more for loops than while loops, but you're going to be writing both, I promise you, in this class. It'll happen. And so with that in mind, let's take a look at this example where you're given a while loop. I want to turn it into a for loop. How do I do that? Type the word for, followed by your parentheses. And then literally for me, it's just as easy as copy pasting in the three pieces. Here's my initialization. Here's my condition. And here's my update. I need a semicolon there. I didn't have to type this out. I just copied the pieces. This is my loop body, so I'll go ahead and, oops, not there. I'll go ahead and paste that in between the brackets. And I have now rewritten this while loop to be in the form of a for loop. There are a couple of errors you can see. One I made intentionally. This is one that honestly drives me a little crazy because you do need this semicolon. You do need this semicolon. However, this one, nope, doesn't go there. Don't ask me why. I didn't make the rules. I just follow them. Seems a little weird to me, but that's how it is. The other problem that it's complaining about is not so much related to the loops and more with the variable. I already created this variable up here, so it's like you don't need to create the variable again. Why are you trying to create the count variable again? It already exists. So I really don't need this. I can take this off, and now it's truly happy. If I print this out, we'll see the values from 1 to 5, I'm sorry, from 5 to 10 get printed out twice in a row. This is from the while loop, and this is from the for loop. They are both doing exactly the same thing, just with a slightly different structure. Yes?
I don't really understand how they're different if they're like inputting the same things into both of them. You said one of them you don't need to know the amount of repetitions, but they do.
Okay, so imagine the example I gave for you don't know the number of repetitions is I have a person involved. So I am quite literally saying scanner in equals new scanner, right? All this stuff. And asking them a question. Oops, I don't need brackets there. Why did I do that? I'm going a little fast and loose here. I'm not worried about correctness as much as trying to answer your question. So now I'm saying, you know, I have some value that I'm asking you to guess. And I want to keep asking you to type in a number over and over and over again until you get it right. How many times is that going to take? I literally do not know. That depends on whoever's sitting at the computer. I could not possibly know that ahead of time. So if I tried to write that with a for loop, that's going to get really tricky. What should this number start at? What should this be? How many repetitions do I want to include? I don't know. I don't know. Depends on whoever's sitting there. Yeah. Does that help kind of illustrate? All right. Let's take a look at this last example for the day. It's about nested loops. And this is such an important example that I promise you we're going to go through an example very similar to this next week. This is not a topic that is just going to be a one and done. We're going to see this pop up in a few different places. I want to make sure everybody really gets it. So what I want to do with the last few minutes of class here is run through this one in the debugger. I have two loops. I label this one the outer loop, and I label this one the inner loop. But think about what that means. I would say that this loop is nested. This loop is inside of this loop, which means that, okay, this loop looks like it's going to repeat 5 times from 1 through 5, correct? But this entire loop is going to be repeated 3 times. So this loop that repeats 5 times is going to be repeated 3 times, which means I'm going to have a total of 15 trips through that inner loop. Does that make sense? I can actually prove that to you, and I would like to, with the debugger, with the few minutes that we have remaining. I have my breakpoint set here on line number 8. I'm going to start us up in debug mode. And I want to track our path through these loops. I haven't done anything yet. So I'm sitting here on the outer loop, and the first thing that's going to happen is I'm going to create my loop variable and start going through these repetitions. So I see row appear as 1. I'm now about to start my inner loop, and this inner loop should repeat 5 times. I can see that just based on the numbers that are given here. We can actually also see that as we step through the loop. Here comes repetition number 1. There's my first star. Repetition number 2. There's my second. 3. You can see the column variable counting up. Notice the row variable has not changed. It is still 1, right? So this outer loop is doing its 5 repetitions while the inner loop is doing its 5 repetitions while the outer loop is sitting here waiting for it to finish doing those. So the outer loop's chilling while the inner loop finishes its 5 repetitions. Here's repetition number 5, and think about what happens next. The column is 5, I can see that. I add 1 to it, that makes the column be 6. 6 is not less than or equal to 5. So my for loop, my inner for loop is over. All of that happens when I click this button. You can see that it has made all of that determination and jumped down here. What's this line doing? System out, got print line. This just bumps us down to the next row. It's a very old analogy, but I equate it to the old school typewriters. Taka, 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 taka. You get to the end of the row, ka-ching, right? That's what that line's doing. It's moving us back to the beginning of the next row so that I can start printing out more stars. And so this loop did its 5 repetitions, but this loop has only done 1 of its 3 repetitions. So we have 2 more repetitions to go. If I keep stepping through, we'll see that, okay, now row is bumped up to 2. I'm on my second trip through the outer loop, and I'm going to do the inner loop again, all 5 times. All 5 times. So we step through this 1, 2, 3, 4, 5. There's my 5. I now am done with that loop. I move down to the next row, and I take my third and final trip through the outer loop. At this point in time, the inner loop just finished. The outer loop, row is 3. It's about to be 4. 4 is not less than or equal to 3, so this outer loop is now finished, which should wrap up the entire program. This is what's known as a nested for loop. It's a very common structure. And while it might seem a little bit confusing, a little bit intimidating, like I said, we're going to see this again next week. It's not going to stop happening. So, yeah, I think that's going to do it for now. Let me know if you have any questions. Otherwise, I will see you in the labs on Wednesday and Thursday. Have a great week, everybody.